Alright guys, we're going to go ahead and take a look at evaluating the nth roots and using rational exponents. So the first thing we want to do is to describe the relationship between the square root of x and x to the power of 1/2. Are these two related at all, or are they going to give us two different values? So let's try a couple of these. I know that the square root of 4 is equal to 2. So I can go ahead and fill these in for the rest. I know that the square root of 100 is 10. And the square root of 9 is 3. Now I'm saying, well, what about 4 to the power of 1/2? So if I go ahead and plug that into my calculator, okay, if it turns on for me, 4 raised to the power of 0.5, if I hit enter, I get 2 for my answer as well. So if you would like, I suggest pausing this video and go ahead and evaluating 100 to the power of 1/2 and 9 to the power of 1/2. So if you would like to do that, please go ahead and pause now. Okay, if you plug those into your calculator, you should have found that 10 to the power, or 100 to the power of 1/2 was in fact equal to 10 as well. So these two matched up. And 9 to the power of 1/2 gave us 3 as well. So these two matched up. Okay, so we should be able to see that we can go back and forth between radical form and rational form, where our exponent is a rational number. Now, what if we have a different number? Okay, so over here, I'm basically saying what number times itself is going to give me 27. After some thinking, we should be able to see that we can plug in 3. But I also want to know, is 27 raised to the power of 1/3 going to be the exact same thing? So if I pull up my calculator, let's try this. If I have 27 raised to the power of 1/3, don't forget your parentheses if you're using a fraction. If I hit enter, I get 3 for my answer as well. Now, taking a look at letter E, let's go ahead. Taking a look at letter E, let's go ahead and identify something. We see that this number, whatever number is in front of my radical, I'm going to go ahead and call that my index. Okay, and also I see the same number in my numerator. So whether I am in radical form and I have a number in my index, or I am in rational form and I have a number in my denominator, these are going to wind up giving me the exact same answers. Okay, so if there is a number in our index, the same number is going to show up in our denominator if we go back and forth. Okay, so let's take a look at a couple key concepts from your textbook, okay? So, we say if we have base A raised to the power of m over n, I can go ahead and rewrite this as A to the power of 1 over n raised to the power of m. If I have a power to a power, I know I'm going to wind up multiplying, so m times 1 over n does give me m over n. Now, we said if we have a number in our denominator, I can also go ahead and put it in my index. So this is how we can finally wind up. Again, if we are going from rational form to radical form. Okay, likewise, if we have a negative exponent, I'm going to go ahead, the first things first, I'm going to put it in the denominator. And I'm going to follow the same steps. I can go ahead and rewrite this as 1 over a to the power of 1 over n raised to the power of m. So we're going to use these to simplify a couple problems. The only thing that we have to remember for the second one is that our a value cannot equal 0. So I would go ahead and write that warning down. Okay, so for these first two, let's do the first two together and you can try the second two on your own. Okay, for letter A, I can see that I have a 2 in the denominator. If it's in the denominator, I know that it can go into my index. So I'm going to make myself a note. So I'm going to write this as the second root of 16 raised to the power of 3. Now, we need to say what number times itself is going to give me 16, or what's the square root of 16? Hopefully, we recognize that that's 4. I'm going to leave that power of 3. So 4 raised to the power of 3 gives me 64 as our answer. Okay, for letter B, I see that I have a negative exponent, so I'm going to have to go ahead and write it in the denominator. So I have 32 to the power of 3 over 5. This number is in my denominator, so I'm going to put it in my index. And I'm going to cube it. Now, we're saying what number times itself, times itself, times itself, times itself gives us 32. Hopefully I can see that the fifth root of 32 gives me 2. And of course 2 to the third power gives me 8. So I should have 1 over 8 as my final answer. Now, I would like you at this point to please pause your video and try C and D on your own. Please start it back up to check your answers. Alright guys, so for the second one, 2 is in my denominator. I'm going to go ahead and put it in my index. If there's an index of 2, we're saying what is the square root of 4? So we should see that that's 2. So 2 to the fifth power gives us 32. For letter D, I see that I have a negative exponent, so I know right away it has to go in the denominator. Whatever's in the denominator of my fraction or my exponent is going to go in the index. Again, we said if there's a 2, I'm going to take the square root. So the square root of 25 gives me 5. So I am left with 1 over 5 as my final answer. Go ahead and flip your page over. Okay, so key concept. We're looking at 2 different situations. The first one, we're saying what if n is an even integer? If n is an even integer and a is less than 0, I have no real roots. So I'm just going to go ahead and write 1. If a, or I'm going to write none, I'm sorry. If a is equal to 0, I have 1 root, and that's going to be in the form of n, so the nth root of 0 equals 0. And if a is greater than 0, I have 2 real roots, and those are going to be in the form of plus or minus the nth root of a. If n is an odd integer, I'm going to take a look at a is less than 0, a is equal to 0, and a is greater than 0 as well. If a is less than 0, with n being odd, I'm going to have 1 real root. Okay, and it's actually going to be true for the other 2 situations as well. I'm going to have 1 real root for any of these. For the first one, if a is less than 0, the root is going to be in the form of the nth root of a. If a is equal to 0, my root is going to be the nth root of 0, which does give me 0. And finally, if a is greater than 0, my root is going to be in the form of the nth root of a as well. Okay? So let's try a couple of equations using what we just learned. My goal here is to get x to the fifth power by itself. So the first thing I'm going to do is multiply by 2 on both sides. So that's going to cancel out my fractions. I'm going to have x to the fifth power equals 1024. I want to go ahead and cancel this fifth power. So if I'm doing that, I'm going to raise each side to the power of 1 over 5th. 5 times 1/5 gives me 1, so my exponent cancels. Now, I see that my a value is greater than 0 and n is odd. So based on what we wrote right above, I'm going to have 1 real root. And I should see, if I plug this into my calculator, 1024 to the power of 1 over 5th, that x equals 4. Okay? Now, over here for the second one, I still want to get x by itself, but before I do that, I need to cancel out that power of 4. I need to unlock the parentheses. So I'm going to raise each side to the power of 1/4. Now, I should see that I have an even exponent, and a is greater than 0. So I'm going to have 2 real solutions. So 4 times 1/4 cancels, so I'm going to have x plus 5 equals 16 to the power of 1/4. We want to make sure that we are putting parentheses around our exponent if we're plugging it into our calculator. And since I have 2 solutions, I should have a positive value and a negative value. So I'm going to wind up with plus or minus 2. Now, getting x by itself, I'm going to go ahead and subtract it from each side. And I should see that x equals -7 and -3. So I do have 2 solutions. Once again, please go ahead and pause your video and try the second 2 problems. Okay, taking a look at the third one, I'm going to go ahead and multiply by 4 on each side, so it's going to cancel out my fraction. So I'm going to be left with x to the third power equals 8. And finally, I'm going to go ahead and take the cubed root of both sides. So I should have 8 to the 1/3 power equals 2. Since a is greater than 0 and I have an odd exponent, I'm only going to have 1 solution. So x equals 2 is my only answer. For the last one, I need to cancel this exponent of 3. So I'm going to raise each side to the power of 1/3. I need to make sure that when I put this into my calculator, not only should my base be in parentheses, but also my exponent. Well, as soon as I evaluate this, I should see that negative 14 to the power of 1/3 gives me negative 2.41. And as soon as I add 2 to both sides, I'm going to get one answer of x equals negative 0.41 because I have an odd exponent. Okay, so let's take a look at a couple more things. I'm going to let you skip the last couple of problems and we'll try them in class on Friday. So for the first one, if I have an exponent of 3 and a of 200 and negative 216, I can rewrite this as negative 16 to the power of 3. And I know I can rewrite this as the third root, or 1 over 3, I'm sorry. I can rewrite this as the third root of negative 216. Okay, so that should give us a final answer of negative 6. Okay, similarly, if n equals 4 and a equals 81, I'm going to put that n value in my index. I'm looking for the fourth root of 81, which I can rewrite as 81 to the power of 1/4. And I should get 3 as my answer. So the biggest thing that we want to walk away with today, whatever number is in my index is also going to go into my denominator. So I should be able to go from radical form to rational form. And I should be able to recognize that these are going to give me the same answer. So if I can't evaluate the fifth root of some number in my calculator, I can make sure that I just change forms, use parentheses, and then I can wind up with the answer that I am looking for. Okay, so once again, please go back, review, and rewind this video. If there's anything that you didn't catch, please make yourself some notes if there's anything that you would like me to clarify in class tomorrow. We'll see you later, guys.